Preparing for a monitoring engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between monitoring and observability? Monitoring tells me whether known conditions are healthy, like CPU usage, disk space, or endpoint availability. Observability helps me understand unknown failure modes by using metrics, logs, and traces together. In practice, I monitor golden signals such as latency, traffic, errors, and saturation, then use observability tooling to debug why an alert fired. Strong monitoring detects symptoms quickly. Observability shortens investigation and recovery time during incidents. While answering, focus on known versus unknown failure modes, the role of metrics, logs, and traces, and how monitoring detects symptoms while observability supports root cause analysis. Question 2. How does Prometheus collect metrics? And when would you use a push-based approach? Prometheus mainly uses a pull model. It scrapes HTTP endpoints, typically /metrics, on a configured interval. This works well for long-running services because Prometheus controls scrape frequency and target health visibility. For short-lived batch jobs, I use push gateway so metrics are pushed before the process exits. I avoid push gateway for normal services because stale metrics and lifecycle ownership become tricky. Pull-based monitoring is simpler, more observable, and easier to secure consistently. Make sure to cover Prometheus scraping, service discovery, exporters, pull versus push trade-offs, push gateway use cases, and why long-running services usually expose metrics endpoints. Question 3. What makes a good production alert? A good alert is actionable, urgent, and tied to user or business impact. I avoid alerting on raw CPU spikes unless they threaten availability. Instead, I alert on symptoms like high error rate, SLO burn rate, queue backlog, or failed checkouts. Every alert should have an owner, severity, dashboard link, and runbook. If nobody needs to wake up and do something, it should be a ticket or dashboard signal, not a page. In your answer, talk about user impact, actionable thresholds, severity, runbooks, ownership, deduplication, and avoiding alerts on symptoms that do not require human response. Question 4. How would you reduce alert fatigue in an operations team? I start by auditing the last few weeks of alerts, which ones paged, which were ignored, and which had no action. Then I remove non-actionable alerts, tune thresholds, add grouping, and suppress dependent alerts during known upstream failures. I prefer SLO burn rate alerts because they capture sustained user impact better than static thresholds. Finally, I review alert metrics regularly, like pages per engineer and false positive rate, because alert quality decays as systems evolve. Be sure to mention noisy alerts, deduplication, suppression, maintenance windows, severity levels, SLO-based alerting, ownership reviews, and measuring alert volume over time. Question 5. Explain SLI, SLO, and SLA with an example. An SLI is the measurement, an SLO is the internal reliability target, and an SLA is the external contractual promise. For an API, my SLI might be the percentage of successful requests under 300 milliseconds. The SLO could be 99.9% monthly compliance. The SLA may promise customers 99.5% availability with penalties. The gap gives engineering room to operate. Error budgets help decide when to prioritize reliability work over new features. While answering, cover the definitions, how SLIs are measured, how SLOs guide engineering decisions, how SLAs are contractual, and why error budgets matter. Question 6. How would you monitor a Kubernetes cluster? I monitor Kubernetes at multiple layers. At the node level, I track CPU, memory, disk, network, and kubelet health. For workloads, I watch pod restarts, crash loops, pending pods, resource limits, and replica availability. Kube state metrics gives object state, while cAdvisor provides container resource usage. I also collect application metrics, logs, and Kubernetes events. The best alerts focus on service impact, like unavailable replicas or unschedulable workloads, not just infrastructure noise. Make sure to cover node, pod, container, control plane, cube state metrics, application metrics, logs, events, resource saturation, and alerting around availability and scheduling failures. Question 7. What are the golden signals, and why are they useful? The 4 golden signals are latency, traffic, errors, and saturation. They give me a compact view of service health. Latency shows how long requests take, traffic shows demand, errors show failed work, and saturation shows resource pressure. For a web API, I graph P95 latency, request rate, 5xx rate, and CPU or connection pool usage. They are useful because they connect infrastructure behavior to user-visible outcomes quickly. In your answer, discuss latency, traffic, errors, and saturation, how they apply to services, and how they help create practical dashboards and alerts. Question 8. How do you choose between white box and black box monitoring? White box monitoring uses internal signals from the system, like queue depth, cache hit rate, garbage collection, and database pool usage. Black box monitoring tests from the outside, like a synthetic login or health check from another region. I use white box data to diagnose causes and black box checks to validate user experience. The two complement each other. A service can have healthy internals but still fail externally because of DNS, TLS, routing, or dependency issues. Be sure to mention internal metrics, external probes, synthetic checks, user perspective, failure coverage, and why mature systems usually need both approaches. Question 9. What is metric cardinality, and why can it become a problem? Metric cardinality is the number of unique time series created by metric labels. For example, request count labeled by method and status is manageable. But adding user ID or request ID can create millions of series. That increases storage, memory, query latency, and sometimes crashes the monitoring backend. I design labels around bounded dimensions like service, endpoint, region, and status. High cardinality details belong in logs or traces, not core metrics. While answering, focus on label combinations, time series explosion, storage and query cost, high cardinality labels like user IDs, and safe label design practices. Question 10. How would you troubleshoot a sudden spike in API latency using monitoring data? I first confirm whether the spike is real using P95 and P99 latency, not just averages. Then I compare traffic, error rate, saturation, and recent deployments. If only one endpoint or region is affected, I narrow the scope. Next, I inspect dependency metrics such as database latency, cache hit rate, and downstream errors. Traces help identify where time is spent. If a deployment correlates strongly and impact is high, I roll back while continuing investigation. Make sure to cover checking latency percentiles, error rates, traffic changes, dependencies, resource saturation, deployments, regional impact, logs, traces, and rollback decisions. Question 11. What are histograms and summaries in Prometheus, and when would you use each? Histograms and summaries both measure distributions, commonly request latency or payload size. A histogram stores counts in configurable buckets, so Prometheus can aggregate across instances and calculate quantiles with histogram quantile. A summary calculates quantiles on the client side, which can be accurate locally, but is harder to aggregate globally. In distributed services, I usually prefer histograms because fleet-wide P95 and P99 latency are more useful than per-instance quantiles. In your answer, talk about buckets, quantiles, aggregation, client-side versus server-side calculation, latency tracking, and why histograms are often preferred in distributed systems. Question 12. How would you design a monitoring dashboard for a critical payment service? I design the first row for fast decision-making: payment success rate, authorization rate, error rate, P95 latency, and traffic. Then I add breakdowns by provider, region, payment method, and status code. Dependency panels show gateway latency, database health, queue backlog, and cache performance. I include recent deploy markers and links to logs and traces. A good dashboard answers 3 questions quickly. Is it broken? Who is affected? And where should I investigate next? Be sure to cover audience, top-level health, business KPIs, technical golden signals, dependency panels, error breakdowns, latency percentiles, and drill-down paths. Question 13. How do you monitor log pipelines to ensure logs are not silently dropped? I treat the logging pipeline like a production service. I monitor agent health, ingestion rate, buffer utilization, dropped events, retry counts, indexing latency, and storage errors. I also compare expected versus actual log volume by service to detect silent loss. For critical paths, I use canary log events and alert if they do not appear in the destination within a threshold. Sampling and retention policies should be explicit, so engineers know what may be missing. While answering, discuss ingestion rate, agent health, buffer usage, delivery failures, indexing latency, sampling, back pressure, dead letter queues, and end-to-end canary logs. Question 14. What is distributed tracing, and how does it help in microservices monitoring? Distributed tracing follows a request as it moves across services. Each operation becomes a span, and spans share a trace ID through context propagation. In microservices, this is powerful because a slow checkout may involve API, inventory, payment, fraud, and database calls. Tracing shows which hop consumed time or returned errors. I usually correlate traces with metrics and logs. Metrics tell me something is wrong. Traces often show exactly where. Make sure to mention trace IDs, spans, context propagation, service dependencies, latency attribution, sampling, and correlation with logs and metrics. Question 15. How would you monitor databases from an application reliability perspective? I monitor databases by combining internal health and application impact. Key signals include query latency, connection pool saturation, active connections, lock weights, deadlocks, replication lag, disk I/O, storage growth, and error rates. I also track slow queries and cache hit ratio. From the application side, I watch timeout rates and dependency latency. The goal is not only to know the database is busy, but whether it is hurting user requests. In your answer, cover connection pools, query latency, slow queries, locks, replication lag, disk usage, cache hit ratio, errors, saturation, and application-facing symptoms. Question 16. How do you set alert thresholds for CPU, memory, and disk usage? I do not set generic thresholds blindly. I look at historical patterns, workload behavior, and failure modes. CPU at 90% may be fine for a batch worker, but risky for a latency-sensitive API. Memory alerts should consider leaks, OOM risk, and container limits. Disk alerts need both percentage and growth rate, because 80% on a fast-growing volume can be urgent. I use duration windows and trend-based alerts to avoid paging on short, harmless spikes. Be sure to discuss static versus dynamic thresholds, historical baselines, saturation, duration windows, workload patterns, predictive alerts, and avoiding pages for harmless spikes. Question 17. What should a good incident runbook contain? A good runbook helps the responder act quickly under pressure. It should explain what the alert means, likely customer impact, first checks, dashboard links, useful log or trace queries, and common mitigations. It also needs escalation context, rollback instructions, and safety warnings for risky commands. I prefer runbooks that are short, tested, and updated after incidents. If a step repeatedly fixes the issue, I look for automation rather than manual repetition. While answering, focus on alert context, impact, first checks, dashboards, log queries, mitigation steps, escalation paths, rollback guidance, and post-incident improvement. Question 18. How would you monitor an external third-party API dependency? For a third-party API, I monitor both our calls and independent synthetic checks. Important metrics include request volume, latency, error rate, timeout rate, retry rate, and quota consumption. I break them down by endpoint and region if possible. I also monitor circuit breaker state and fallback usage because those show customer impact. Vendor status pages are useful, but I do not rely on them as the source of truth. Our telemetry matters more. Make sure to cover synthetic checks, latency, error rate, timeout rate, quota usage, regional failures, circuit breakers, fallback behavior, and vendor status correlation. Question 19. How do you handle monitoring during deployments and releases? During deployments, I add deploy markers to dashboards and compare canary metrics against the previous version. I watch error rate, latency, saturation, business KPIs, and dependency failures. For progressive rollouts, I gate expansion on healthy metrics and roll back automatically for clear regressions. I avoid blanket alert suppression because deployments are when alerts matter most. Instead, I tune alerts to reduce noise while preserving user impact signals. Good release monitoring makes rollback a routine decision, not a debate. In your answer, discuss deploy markers, canary analysis, baseline comparison, automated rollback signals, error budgets, dashboards, alert suppression risks, and progressive delivery. Question 20. How would you build a monitoring strategy for a new service from scratch? I start by defining what reliability means for the service: availability, latency, correctness, and business outcomes. Then I instrument golden signals, key dependencies, resource usage, structured logs, and traces. I create dashboards for service owners and alerts tied to SLOs or clear failure modes. Before launch, I add runbooks and ownership. After launch, I review incidents, noisy alerts, and missing signals. Monitoring should evolve with the service, not remain a one-time setup. Be sure to cover defining SLIs, instrumentation, dashboards, alerting, logs, traces, ownership, runbooks, dependency monitoring, capacity signals, and iterative improvement after launch. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.